You've seen them, probably. Maybe you've even used them yourself.
Hmm.
Those wild, creative, sometimes kind of uncanny special effects that pop up all over TikTok.
Right, yeah.
What if we told you that behind that fun filter, or that augmented reality mask, there's some incredibly advanced, really cutting-edge AI technology making all that digital magic happen, like right there on your phone in real time?
It's absolutely true.
Mm.
And today, we're doing a deep dive into the source material. It's an article that really pulls back the curtain on the technology powering Douyin, which is the Chinese version of TikTok.
Okay.
And our mission, really, is to understand the core AI techniques ByteDance, that's the parent company, uses to create these effects. And, maybe more importantly, figure out why it all matters for the platform's success and, well, the future of mobile tech.
Yeah, this article gives us a really fascinating look inside the tech engine of one of the world's most popular media platforms. It reminds us right up front that ByteDance is just this massive force in short video in China. Douyin is used by huge numbers of people, all sorts of age groups too, not just, teens anymore.
Definitely not just teens. And TikTok, of course, is the international version we're mostly familiar with.
Right.
So the core idea in the article is that a key driver of Douyin's huge popularity, beyond just being a place to watch videos, is this massive library of special effects. They call them UTI, Douyin Special Effects.
Doing special effects. God.
And they're available right there when you're filming. A huge number of these are powered by pretty advanced AI. The article even calls ByteDance a world leader in image generation tech.
Wow.
So yeah, we're going to try and uncover the specific tech behind some of these super popular effects.
Okay, let's unpack this then. The article starts by putting short video in context. It's become like fundamental media in China. There was a 2021 media report mentioned by CTR, ranked short video fourth by user count and daily usage time. That's huge.
It really is. And the article digs into why it's so engaging. Beyond just the numbers, it calls it efficient. Like, there's no waits.
Efficient. How so?
Well, unlike traditional videos or TV maybe, where you might sit through intros or whatever, the most interesting part of a short video, it usually starts immediately.
Yeah, okay, I totally get that. Instantly if you're hooked or if you should just swipe.
Exactly. And the article captures this feeling with this idea that time feels denser.
Time feels denser.
Yeah, because the videos are short, maybe 15, 30 seconds, and you can skip the ones you don't like super easily. You could watch like over 100 videos in just half an hour.
Ooh.
Which creates this really high sense of rapid satisfaction.
Okay, rapid satisfaction, denser time. I see it.
And underpinning all that, of course, is the recommendation engine.
Ah, yes, the algorithm.
Right. As the article briefly mentions, and we've touched on this before, the incredibly well-designed machine learning system that feeds you videos it thinks you'll love, well, it creates that infinite stream feeling, which can be pretty absorbing.
Absorbing is one way to put it. The article does mention the platform's response, right? That little gentle nudge, maybe it's time to sleep after about an hour of constant watching.
A small nod to how sticky it is.
Yeah.
Right. But, while watching is massive, the article also highlights that Douyin is an incredibly powerful and, frankly, fun tool for making videos too.
Okay, so shifting from watching to creating.
Exactly. Focusing on the creator experience.
And this is where it gets really interesting, I think, from a design perspective. The article points to what it calls a revolutionary decision, making vertical video the default.
Seems obvious now, maybe.
Well, yeah, but back then, it perfectly aligns with how we naturally hold our phones, right?
Yeah.
A big shift from that old horizontal camera or TV thinking, and it makes framing people way easier, especially for like selfies or dances.
Totally. And the user interface for actually shooting.
Sure.
It's surprisingly innovative. The article explains, most video apps used a button you tapped once to start, again, to stop.
Standard.
Yeah. Douyin use a button where you press and hold to film and release to stop.
Okay.
But here's the detail that kind of surprised me reading this. If you press the button, then move your finger around the screen while still holding it down, the button actually follows your finger.
Wait, the button follows you? Why? What's the point of that?
It's actually a really brilliant bit of UX design. The article explains it's to make sure that if your finger slips or just moves a bit while you're holding it down during a dynamic shoot, like say you're dancing or moving the phone around a lot,
Right.
you don't accidentally lift off and stop recording.
Ah, okay. It maintains the contact.
Exactly. Keeps the recording going.
That makes so much sense. And the outcome of that simple UI change.
Well, the article describes it as allowing you to swing the camera freely. You can film yourself dancing, moving around dynamically without needing to constantly stop and restart.
Yeah.
It apparently totally changed the user experience.
Enabled new angles, a new sensation in video creation, as the article puts it.
Yeah, and it just dramatically lowered the barrier to entry for making interesting videos. All you really need is your phone, an idea, and, maybe a willingness to experiment a bit.
And this ability to easily create these unique dynamic videos, that's a huge part of the appeal, right? And enabled by the tech we're about to get into.
Heavily enabled by ByteDance's AI, yeah.
Okay, so this leads us right to the real magic, those special effects.
Right, and the sheer scale the article mentions is pretty impressive. ByteDance provides this massive library of AI-powered effects, and get this, they add over 100 new ones daily,
100 new effects every single day.
every day. Users often just discover them by seeing them in someone else's video and tapping a button to use the same one. Super easy sharing.
That's wild. The volume is incredible.
And the popularity stats are telling. The article notes about 20% of videos use some kind of effect, and over 80 million users have tried an effect at least once.
Okay, 20% is significant. And the number one effect, according to the source,
The beauty filter.
knew it, or I suspected it.
Yeah, it's incredibly popular,
Yeah.
especially with younger users, the article notes, but honestly, probably across demographics.
Oh, it does more than just smooth things out, right?
Oh, yeah, way more. The article describes its capabilities. It's real-time skin smoothing, yes, but also reshaping the jawline, making eyes seem bigger, adjusting lip and nose shape. It can even do full-body tweaks like making legs look longer or the waist slimmer.
Wow. It creates, as the article puts it, a version of you that's more beautiful than reality.
Mm-hmm. And that's hugely appealing, especially as the source mentions, for people maybe with appearance complexes. It offers them another self in doing, a self that might get more positive feedback online. It's a powerful psychological draw.
Definitely. And it's all enabled by this tech. But how? How is this magic camera thing actually achieved running in real time on just a phone?
Right. This is where ByteDance's technical skill, which the article really highlights, comes in. The underlying tech, it involves really high-precision face recognition, some advanced AR techniques, deep learning models like GenANs, and also really sophisticated computation compression.
Okay, lots to unpack there. Let's start with the foundation, face recognition.
Yeah, the foundation for so many effects is this incredibly precise face recognition and tracking.
Now, face recognition is pretty common now, right? Like phones use it.
True, but the article emphasizes the level of precision needed here is way beyond just unlocking your phone. It needs to be good enough to make computer graphics stick seamlessly, like naturally, to a face that's moving, talking, expressing, all in real time.
Okay, so what's involved?
The article details a multi-step process. First, there's face detection, just quickly finding the face in the image. They use techniques like searching with different size boxes, checking for characteristic light and dark patterns really fast.
Finding the face. Step one.
Then, once potential faces are found, it moves to feature point extraction.
Feature points, like the corners of your eyes, mouth, tip of the nose, that kind of stuff.
Exactly. And the number of points matters a lot here. The article notes, for something simple like face authentication, maybe you only need around 70 points.
Okay.
But for tracking a face, for these special effects where the CG needs to, deform with expressions and follow movement precisely, they use 107 points.
107 points. Okay, that's a lot more granular detail.
It really is. And these points are then connected to create what they call a face mesh model.
A mesh, like a 3D map of the face.
Basically, yeah. The article explains it starts maybe a bit rough, but gets much more precise as the face moves and rotates. And critically, it understands the 3D structure, not just a flat image, even if the face is tilted or angled.
And that's the key, isn't it? This precise, dynamic 3D mesh. That's what lets the CG, whether it's makeup or a mask or foam, stick to your face and follow all its complex movements naturally.
But that's exactly it. It sticks convincingly in real time.
So let's look at an example the article uses that shows this off. The Hue, the milk bottle mask effect.
Ah, yeah, the milk foam one.
I have definitely seen that. Looks like you have, milk foam all over your face.
Precisely. The article includes examples showing how this CG foam follows the face perfectly as it moves, rotates, because it's mapped right onto that dynamic 3D face mesh we just talked about.
Okay, that makes sense with the mesh. But there's another detail the article points out that's really revealing, isn't there?
Yes. When the user in the example video covers part of their face, like their eyes or mouth with their hand,
Yeah.
the CG foam doesn't just, disappear underneath. It actually distorts and wraps around the hand, as if the hand is a real solid object interacting with the phone.
Whoa, so it understands there's something in front of the face.
Exactly. That's a significant technical achievement for real-time mobile AR. It shows the system isn't just tracking the face outline, or even just those 107 points rigidly. It's understanding the relative positions of features in 3D space. It detects when they get blocked or occluded by something else like a hand.
And it adjusts the mesh and the CG in real time to account for that blockage.
Right. It shows a really sophisticated level of spatial understanding happening instantly on your phone.
That is much more complex than just slapping a static image on top. Okay, another effect the article mentions is ote, window flower cutting.
Yeah. This one's quite unique. Culturally specific, often used for New Year's, apparently. It uses your nose as a kind of virtual pen on the
Your
screen.
nose as a pen.
Yeah, you move your nose, and it cuts a pattern in this virtual paper on screen, which then unfolds into a beautiful geometric design.
Okay, so the tech there is all about recognizing and tracking the precise position and movement of your nose.
Exactly that. Highly accurate nose tracking. And a simple but really effective feature the article mentions. When you share a video using this effect, the effect itself gets packaged with the video.
Oh, so others can just tap and try it.
Super easily. Makes effects spread really fast.
Smart. What about the peaking opera effect?
Right, this one overlays a really detailed peaking opera headdress and makeup onto your face.
Okay, so similar tech, 3D face model.
Yes, uses the 3D face model like we discussed, and a complex 3D model of the headdress itself. The article points out how the headdress's angle and perspective change correctly naturally as you move your head around.
Looks pretty convincing in the examples.
It does. And here's another impressive detail the article highlights, showing the AI's sophistication.
Hmm.
The little decorations hanging from the headdress, they actually sway.
Sway.
Yeah, according to simulated physics, based on how your head rotates and moves. It shows the AI isn't just tracking position, it's understanding and simulating motion dynamics.
So it looks more grounded, more realistic.
Exactly. Makes the CG feel less like it's just pasted on.
The article does mention, though, that sometimes the CG resolution for effects like this might seem a bit lower.
Yeah, it notes that. Could be a trade-off, maybe to ensure it runs smoothly on older phones, or maybe even a stylistic choice sometimes. But that underlying tech, especially the physics simulation bit, that's still remarkable for a mobile app.
Absolutely. Okay, moving beyond just face effects, the article talks about landmark AR.
Right. This is where you play your phone's camera at specific real-world landmarks.
And stuff happens on screen?
Exactly. Digital elements appear, or the landmark itself seems to change in your video feed.
What kind of examples did they give?
Several cool ones from China. Point at the Xi'an bell tower, a phoenix appears. Point at Beijing Sanlitun, a game interface surrounds the building. Chongqing Hengyedong gets dynamic neon lights. Shanghai's Oriental Pearl Tower starts to look like a space base.
Okay, that's really futuristic. What's the tech there? Is it GPS-based?
You'd think maybe GPS, right? Yeah. But no, the article says this uses image recognition. It identifies the landmark purely based on its visual appearance.
Just by looking at it?
Yep. Once it recognizes it, it overlays pre-made 3D models or effects onto the video feed, perfectly aligned with the landmark. And here's the surprising detail the article points out, because it's image-based.
Yeah.
It doesn't need GPS. It works purely by recognizing the image, which means it even works if you point your camera at a photo or a poster of the landmark.
No way. So you could hold up a picture of the Xi'an bell tower and see the phoenix appear on your phone screen.
According to the article, yes.
Yeah.
It's incredibly clever.
Wow. The article also notes these were often like collaborations for tourism and promotion.
Yeah, Joran mentions that and points out Docomo did something similar in Japan via TikTok. It's a really creative way to blend the digital and physical worlds for engagement or marketing.
Definitely thinking outside the box.
Mm-hmm.
Okay, two other really striking effects mentioned involve image generation. Dynamic old photos.
Right. This one takes an old photo, often black and white. The AI restores it, colorizes it, and then it animates the faces.
Animates them. How?
Makes them subtly smile, maybe move their eyes, blink, that kind of thing. The article describes this creating this really vivid sense of connection to like past family members. Apparently led to some very emotional reactions from users.
Wow, I can imagine. Taking a static memory and giving it a flicker of life, that sounds incredibly powerful. And the other one?
Freeze screen. 3-screen life. That effect shows 3 versions of your face simultaneously, in real time. There's a dynamically generated younger version of you, your current age, and then an aged version.
Whoa. So the AI isn't just tracking or overlaying things here. It's actively creating images that didn't exist before, an aged face, an animated version of a still photo.
Exactly. And this brings us neatly to the core AI tech powering these generation effects, deep learning, specifically often combined with something called GANs.
Okay, deep learning. The article gives a quick refresher, right? Multi-layered neural networks.
Yeah. And traditionally, deep learning often acts as a classifier. You feed it an image, tells you the probability of what it is. Dog, 84%, cat, 12%.
Trained on huge amounts of labeled data, images tagged by humans.
Exactly. But the challenge for generation effects, like
Mhm.
aging a face or animating that photo,
Yeah.
there's no single correct answer image to train against.
Hmm.
You can't easily get millions of photos labeled, this is what this specific person should look like aged 20 years.
Yeah, how would you even create that training data? And having humans evaluate every generated image during training, that would be impossibly slow.
Totally impractical for the scale needed. So how do you
Huh.
train an AI to create incredibly realistic images when you don't have millions of pre-labeled correct outputs?
That's the
And this is where GANs come in, generative adversarial networks. The article highlights this as a really elegant solution. You use two AIs.
Do.
Yeah, two AIs set up to compete and learn from each other.
Ah, right. The analogy, the article uses the forger and the bird appraiser.
It's a perfect way to grasp it. One AI is the generator, that's the forger.
Mm.
Its job is to try and create super realistic fake images. Could be a face, an animal, whatever the task is.
Okay, the forger makes fakes.
The other AI is the discriminator, the art appraiser.
Right.
Its job is to look at images, some real, some fake from the generator, and try to spot the fakes, to tell them apart from the real ones.
And they learn by trying to trick each other.
Precisely. The generator makes an image. The discriminator evaluates how real it looks, basically giving feedback like, nope, I think that's fake, or wow, that looks real.
Okay.
That evaluation, that feedback, gets sent back to the generator. It tells the generator where it messed up or what worked, helping it improve its forgery skills for the next try.
So they both get better and better through this constant competition.
Exactly. Rapidly. The generator gets better at making fakes. The discriminator gets better at spotting them.
And this whole adversarial process, it lets them learn to create incredibly realistic images of things that maybe don't even exist in the original training data.
Exactly right. Like generating human faces that have never existed. Or that classic example of turning photos of horses into zebras using cycle GANs. The article also mentions GANs being used now for generating virtual characters, AI news anchors or bots for live commerce online. We're seeing more of that stuff.
Okay, so deep learning joins. Clearly super powerful for generating and transforming images, but there's got to be a catch, right? Especially for an app like Douyin or TikTok. These effects have to run in real time on millions of different phones.
That is the major challenge. Computation. Deep learning models, especially these complex generative ones like GANs, need massive amounts of computation.
Right, which is fine if you're, say, a self-driving car with dedicated, powerful AI chips built in.
Right. But smartphones, they have pretty limited processing power, limited battery. It's a totally different ballgame.
So how do you get these incredibly complex, computationally heavy AI models to run smoothly, in real time, on just an ordinary smartphone?
This is where ByteDance's apparently focus really heavily. Computation compression technology. The article details it, and it describes a key technique they use called distillation.
Distillation, like purifying alcohol or something.
That's actually not a bad way to think about it. The technique involves training a really big, powerful teacher AI model first. This happens offline on high-spec computers.
Okay, the big teacher model learns the complex task, like how to age a face realistically.
Exactly. Then you train a second AI model, a much smaller, lighter student model. But here's the key. The student isn't trained to replicate the teacher's complex process or its internal workings. It's trained just to reproduce the results, the outputs of the teacher model as accurately as possible, but much more efficiently.
So the student learns the high-quality answers from the teacher, but without having to do all the teacher's heavy computational thinking to get there itself.
Precisely. The article uses a great analogy, the quadratic formula in math, deriving that formula from scratch. That involves complex calculations, deep understanding of algebra that's like the teacher model. But once you have the formula, just memorizing it and applying it to get the answer, that's much faster, much less computation, but yields the same correct result. That's like the student model.
Got it. So distillation lets that fast, efficient student model run smoothly on a phone, giving you results that are almost as good as the massive teacher model.
Exactly. And ByteDance has clearly had real success with this.
Yeah.
The article mentions a published paper where they showed they compressed the computation needed for a specific type of GAN, a cycle GAN, often used for image translation tasks like changing appearance.
Yeah.
They got the computation down to an incredible 146th of its original requirement using this kind of distillation technique.
146, that's a massive reduction in computational costs.
It really is. It highlights their focus isn't just on developing the cutting-edge AI, but on making it practical.
Yeah.
Making it work in the real world, in real time, on mobile, at a massive scale.
Yep.
So the article concludes by summing up ByteDance's strength here. It states they are at a, quote, very high level in AI use on smartphones, especially in areas like entertainment, image generation, and transformation.
It also touches on the nature of the field itself, right? That deep learning still has these black box elements. We don't always know exactly how it reaches a specific result.
Right. It's not all perfectly understood theoretically yet. So success depends heavily on just doing it, extensive trial and error, practical experience, iterating really fast based on real-world data and results.
And this dependency on practical experience, on iteration, that creates a pretty big first-mover advantage, doesn't it?
Huge. The article subtly addresses that idea that some people might think current AI is, overhyped.
Yeah.
It explains that tech companies are pushing AI so hard right now precisely because of this first-mover advantage. If you wait until AI is fully practical or perfectly understood, well, there might be no room left for you to enter the market or compete effectively. The leaders will be too far ahead.
So for ByteDance, developing these effects isn't just about building cool features for users. It's a strategic move to secure their position by mastering mobile AI now, while the field is still being defined by practical application.
Precisely. They're leveraging that massive user base they have to fuel that essential cycle of trial, error, data collection, and refinement. It's critical in this field.
So to bring it back to you, the listener,
Mhm.
many of these incredibly powerful, really sophisticated effects we've just been talking about, they're available globally right now on TikTok.
Yeah. So the next time you're scrolling through your feed, or maybe even playing around with the effects yourself, maybe take a second to appreciate the sheer level of artificial intelligence technology that's working behind the scenes, in real time, on your phone, to create these engaging, often surprising visuals.
It really helps you realize that TikTok's staggering global popularity isn't just about viral dances or trends. It's directly tied to this incredibly sophisticated technology that makes creating and watching videos so compelling, so accessible, and so unique. It's not just the content, it's the tools enabling it.
It truly shows how advanced AI isn't just something happening in research labs or, self-driving cars anymore. It's fundamentally transforming how we create and interact with visual media right in our pockets.
Yeah. I mean, we've seen AI today that can make old family photos move, generate realistic faces that don't even exist, understand 3D space well enough to wrap graphics around your hand, and reshape your appearance instantly,
Yeah.
all running on a smartphone. It makes you wonder, what does it mean for our understanding of reality when such powerful visual manipulation tools are literally in everyone's pocket? And where might this technology lead us next?